see, I don't have space for it. You see that? Okay, what I'll do is I'll go ahead and I'll draw it in blue for the parent function. The parent function before is transformed or translated. In this case, it's translated only. It looks like this. There's an asymptote that goes basically through the axis, right? And it goes like this. I think if I were to draw this, I'm sure you're familiar with it. It looks like this, right?
And it doesn't like actually touch those lines. It's just like skimming them.
Yes. Now there's more to it. The number one. Now this is something that they do in college. Not all, but most people in college likely know it. Professor do know it. See the box right here? That exactly it's one. If this were two, like this number 3, but I'll show you right now for number 2. Let's do bit by bit.
It's 1 still.
Yes, it's 1. But if it were 2, let's say if it were 2, you will stack 2 boxes up this way, 2 boxes from the origin. You stack them, overlapping them. And then you do it here too. You do it here too. Okay, it looks like this. If this were 2, and then what do you do with that? How do you graph it? Now, without the 5, without the -1 here, okay, for that, for now, you will have to go through the corner of the boxes here. You see it? The corner there, you're gonna connect them. You get 2 points free on the table if you want to show the, like some kind of coordinate, right? Two points. 4 actually altogether, like another 2 here. So I'm going to show you that. I'm going to show you that for number 3, but let's do number 2 first, with the +5 and the -1. Is that okay? So now that you know like the basic parent function, the way it should shape, it's easy. You don't even need to write the table, but you can show 2 points on the table. So but it won't be the transformation table or translation table. But let me show it to you right now. So let's do the fast way. Let me take out see, like this is the thing that I'm not too used to with this particular app, but no biggie. Okay, let's do it now. So now what will happen with the parent function is this. I think you remember the HK. Let's write down the HK. I think your teacher wants to see at least that. So you can write exactly what I write here.
No, it's like part of the, I don't know if you see the part in the
bottom.
Yes. But
Yeah, that's right. HK, vertical. Yes, we'll list all of it right now. Oh yeah, you have enough information for you to do the fast way. You still need to do all the details except this lame table. I'm sorry, I didn't mean to say that, but yeah, it's cumbersome. The table is cumbersome. I can do it, but it will take
really annoying.
Yeah, exactly. It will take quite a bit too to gather them, to gather the values. So HK will be the H will always be the opposite immediately next to the X, which is going to be 1. The K will be exactly the K will be exactly as is 5 on the outside. So 1 opposite here, same here.
Okay.
How do I get my black ink? Okay, from here. That means you're now having to move it. The origin, you can think of the origin being moved at 1, 5. How about that? Is that okay? And then we'll do the asymptotes. 1, 5. Okay. Let's locate 1, 5. 1 and then up 5. So right there. Once you have that point, that represents this particular origin. The graph won't go through there though. However, okay, what will happen is that you're gonna use this as a pivot. How? Well, let's do the.
Is that like the 0, 0 in this?
Yes, it will be 0, 0, and therefore you will get automatically 2 asymptotes. You're gonna get 2 asymptotes immediately from here. 1. Let's do the y asymptote first. So it'll go through this point like this. Okay, dash. Yeah, you should do a dash line there. So you can list the asymptote right now. VA, I'll do VA for vertical asymptote. So VA will be y = 5. HA for horizontal asymptote, I'll actually capitalize it. That's most common. HA will be this particular asymptote, a vertical I got him flipped. Vertical asymptote is x = 1. Is that all right? Is that okay? How do I erase that? Okay. X = 1. And HA, x = 1 for vertical asymptote. HA will be y = 5. Is that okay? Like that?
Okay.
my HA, my BA. Okay, now that's all you need to do, by the way. And then you can do your box right now, like the way I showed you. The box will exist right there. See it? But you got to do like,
Okay.
kind of like diagonally across each other. When it's positive, it will be this configuration. When it's negative, it will be over here, like that. Let me.
Okay.
What do you mean negative? We're negative for the whole thing. That's what I mean.
Like for number 3.
Yeah, number 3. Yes. We'll do that. Oh, right. Yeah, that's good. Let me see. I get my ink back here. Yeah. All right. Get your box here. Your box here, and now all you need to do is basically kind of taper off the graph. Looks like this. Here's the final graph. Taper off. Get close to the asymptote, but never cross over. Yeah. You see how I'm doing that? It's supposed to get real close to the, how do I describe this? So you kind of taper off the top portion, but it gets real close to the horizontal asymptote. And this one get real close to vertical asymptote, but never cross over. Same thing with this one on the bottom here. That's it. That's the graph. You're done. But let me see if we need, okay, now we have to do domain range. Okay, yes. So domain, based on the picture, the domain, right? Based on the cutoff with the asymptote, you can look at it. You can see that it's negative infinity all the way to 1, not including. You see that? Then there's a cut at 1, so a union, and then from 1 to positive infinity. Is that okay?
So because
It's like all the x's. Yeah, it's all the x's. Yeah, all the x's that you exist on the curves. It's split up. The curves split up.
The x's. So the first one goes infinitely negative.
Negative, huh? And then it gets to 1 from left to right. Yeah, and then it gets
gets to 1
and then from 1 to positive infinity. Now realizing something here though, you have to do the smaller number to larger number, small to large. Negative number is really small, right? So and then the larger one is 1, and then from 1 smaller to larger, same thing, small 1 to infinity. There you go. And then the range, same idea. You have to skim from the bottom up, like you're looking from the bottom up. So for the range, it would be from negative infinity all the way to 5.
Negative 5 because the y-axis now, right?
Yes, you're looking at like all the y values. Now, I recommend you actually use the graph when we do number 3. I think you'll be okay, even better with domain and range. You use your graph to help you detail it, like what we're doing right now for the range. So up from negative infinity all the way to 5, right here, like right there, and then from 5 to positive infinity. Then you go from 5 to positive infinity because it's going up from 5.
Okay.
Like that. That's your range. Domain is like domain is like you going like this. See that?
How do you know about increasing and decreasing intervals then?
Okay. Again, you have to look. Well, it looks like it. Again, it's like domain. It looks like you scanning the domain. So you go from left to right. So watch. If you scan it from left to right, always. By the way, if you ever come across increasing decreasing concept in graphing, you have to scan from left to right. So here we go. Let's do this. Okay. So increasing. Oh, actually, it doesn't matter how you write it. Increasing, decreasing. So let's label and be ready for it for both. So it depends, right? It depends on how you see the graph. So now we're scanning from left to right. Okay, left to right. So let's see what it looks like. Let me take those arrow back. Okay, if you scan from left to right, you can see that it's going down like this. You see that? Mm-hmm. It's going down like that. So that, by the way you see it, you want to describe it like this.
So does that mean it's decreasing because
yes,
it goes down first?
Yes, from left to right. So it's the way you label it. It's decreasing from negative infinity all the way to 1, not including. Yeah. So every time you do increasing, decreasing, you never use the bracket. So you always like, yeah, decreasing. Now, you may get confused this part. Continue on, moving on, right? From 1 on, right? From 1 on. There's a break. That's why we're going to use 1 again. But from 1 on, it's still decreasing. I don't know if you can see it because it's going down like this. I know we point the arrow up, but that's the way the graph always. I mean, that's the way you sketch the graph. But when you scan it, it's going down. It's going down. You see it? It's going down. So you have to
Yeah.
go by the way you see it from left to right. So that means decreasing also from 1 to positive infinity. Basically, they're decreasing, but not everywhere. There's a cut between at one at one. That's why you have to split them like that. There you go. So technically, it's like decreasing.
Wait,
I know
so.
how. Ask me, because yeah, this is why I
But I
think
also think of it as like if it's like if there's no negative, like if it's not a negative what graph, it's decreasing. I don't know. Is that just like a way to think of it as well, or
I don't know. I don't know if that is the way I see it. But let me go again.
I don't?
I think
Because I mean, like I think I understand what you mean. Like it's going down,
down for both
right?
portion. If you
Yeah.
look at it from left to right, you see if you. I don't know. I can't block it. Okay, let me do it this way. Let me see if I can bring the. I can't. You see, I'm not as flexible with this particular app.
Yeah.
If you block the at one, if you block the right half of the graph, could you see that it's decreasing
Uh-huh.
on the left on the left side from left to right?
Yes.
Okay, now
Yes.
block the
Yeah.
left side. I'm usually imagining block the left side of the graph. Is it decreasing? You see it? Block. Imagine you put your hand on the right side of the graph, on the left side, on the
Yeah.
left. Do you see it's
Okay.
decreasing? You see it? It's decreased from
Yeah.
yeah. It's going down from left to right from one on
Okay.
from one on. Do you see it now? You
Okay.
think about that. It looks weird
Yeah.
the way they yeah, the way it's curved. It looks weird. Now the
Yeah.
graphing for number one looks better because it has that
Oh,
three.
because
You
it
see
is
it? Yeah,
decreasing.
this, you see that?
Yeah.
That's why. Look at number one. It's the exact same thing, by the way. There you go. Number three will be different because of the negative. I'll sketch that and then you can see it. But
Okay.
right now, can you see number one? It's better. Block,
Yeah.
yeah, block the right side of the graph. You can see that it's decreasing
Yes.
from negative infinity all the way to negative
Okay.
4. Yeah, and then from negative 4, block the left side. It's decreasing again. There you go. Yeah, I hope you're okay with that. All right. Let's and then increasing, guess what? None. I don't know how you write that. NA, whatever.
Just none.
Yeah,
Yeah.
none.
I just
It
say
doesn't
none, but
well, it doesn't exist. It doesn't exist. You say none.
yeah.
Okay, let's do number 3. All right.
There's also x-intercept,
Oh,
y-intercept, and then
oh,
transformations.
right,
Sorry, there's a
right.
lot that we do for these
That's right.
graphs.
Okay, based x-intercept. Let me write up here. Based on the way the graph looks, you can just say, see, doesn't there?
It's that one.
Yeah, it's not quite. By the way, we're gonna have to solve it. You see, it's right there,
Yeah.
and there's a y-intercept right here. I know my sketching is not that great, but
Yeah.
try to make it firm. All
Yeah.
right,
Yeah.
all right. X-intercept, you have to solve it. So to do x-intercept, if you recall, see, I have no space here. Let me write. Oh, I can't even. Why can't I even write that over?
Wait,
Anyway,
go over the.
yeah, this app. Let me see. I can fit in somewhere. Okay, let me fit up here. X and Y intercept looks like this. If you remember, like the table layout
Yeah.
for X intercept, you substitute your Y with 0 and then solve for X. And then vice versa. If you're trying to find Y intercept, you substitute X with 0 and then solve for Y. Like I'm blanking, you know, the
Okay.
X and
Yeah.
blanking
Yeah.
the Y. Okay, then you could do any one, which one first. It doesn't matter which one first. So I'll do the x-intercept first. That means I'll have to substitute y with 0. So y with 0 here. So here we go. I'm going to write the whole equation. So y equals 1 over x minus 1 plus 5.
Okay.
Okay. So
Oh. Okay. Okay.
okay, and then solve for x. Now, careful when solving it. Subtract both sides by 5 first. I'm limited in my space. I hope you're okay. I'm not gonna write the subtract both sides. Just
Yeah.
imagine what happened next, and then put 1 underneath -5 and cross multiplied. That's one way of doing it. Cross multiply means 1 times 1 is on one side of the equation. I'll put it on the right side of the equation. I'm indenting it over, and the left
Mhm.
side it's -5 times that. Now you can write -5 parenthesis x minus 1 to show all the work. Distribute -5x plus 5 equals 1. And then subtract both sides by 5. If you do, you get a negative 4 on this side and negative 5x left on that side. Divide both sides by negative 5. So you're left with 4/5. So x equals 4/5. So if you look in the graph, it's almost 1. Do you see it? It's 4/5 right there. Almost 5/5. So that's your, that is your x-intercept. Okay, y-intercept. See, I'm limited in my space to do the work. So y-intercept, where can I write it? Down here. Y-intercept, you're going to substitute x with, you want to substitute x with, I can't write in a transformation table. Oh, I cannot expand this either. What can I do? I'll put it over here, okay? On this side right here. So for y-intercept, you substitute x with 0. So I'll leave the y alone, substitute x with 0. So 0 minus 1 here, plus 5. Okay? Therefore, you're left with y equals 1 divided by negative 1 is negative 1 plus 5. Do you see that? Negative 1 plus 5. So that is a 4. So y equals 4 is your y-intercept. So I'll write y-intercept up here, y-int dash int is negative 4.
Wait, can you like...
Yes, so right here.
Oh, so we insert 0 for x.
Yes, put 0, substitute x with 0, and compute. 1 over a negative 1 is negative 1.
It's minus 1, and then...
Plus 5, so it's 4. So y
that makes sense.
intercept equals y-intercept is y equals 4. So you can see it. It's actually going through 4 right there. You see it? We get the box. You get that automatically. You see the box tells you that you have to go through that corner of the box.
Okay.
Okay, we got it. Yeah, your teacher should be fine without that table because that's time consuming. That's so much time that you're gonna spend. All right, are we ready for 3? Quickly, let's do it 3. Yeah. So your HK. I need space. Quickly, squeeze it up a little more. Your HK will be opposite again for the x. It'll be 6 comma 4. Your HK. So now locate 6 comma 4 as your point that you're gonna do asymptote through, like the two asymptotes. 6 comma 4, 6 up 4, 6 up 4. Let me double check. Yeah, 6 up 4. So small here. Yeah, okay, 6 4. And then you can immediately do your asymptote. So this is your vertical asymptote and your horizontal asymptote. Like that. Okay. So I'll write the VA here. The VA, vertical asymptote, it's going to be x equals 6. Is this value? Oh yeah. Have you noticed? Is your HK value, your VA. Oh. Yeah. If you look at number 2, your VA, you can make a note on this if you want. Your VA will be your x equals 1. Your HA is your y equals 5. You see that? Okay. Yeah, so therefore VA, vertical asymptote, is x equals 6. Your HA is your y equals 4. Okay. All right, now for a quick sketch without the transformation table, here we go. Now, you have to account for the negative at the same time. Okay, but let me do the positive first. You don't have to copy this down. Let me do the positive. You will stack 2 boxes this way and then 2 boxes this way. Positive, okay? Positive 2. 2 boxes this way, 2 boxes this way. Do you see that? Let me kind of make it more firm. So, but since this is negative, you have to do like a flip, like a mirror image of this here. So it will look like this. Here we go. Oops, I erased too much. Okay, there we go. Okay, so you're going to be doing 2 boxes this way and 2 boxes this way. And then you can do 2 boxes this way, 2 boxes this way from this point. And I'll make it like look square boxes. There you go. You see that? And then you can contour around it. How? You have to touch this 2 points, the corner. So these points will be on the curve. Now if you need to show the table, let me squeeze in the table over here. You automatically get 4 x comma y. Now this x y has to do with the. If I recommend you don't. I recommend you don't actually label x and y because your teacher may think it's the parent function. Remember, like this, like coming from here. Remember that
Yeah.
before you do this, it's like the x y. So therefore, you just go ahead and list it without the x comma y on x y on top. So you're gonna list like what is that? There's 2 points. You can do this. You can do this later. I'll do this point and this point and this point. So what is that? It's going to be 5 comma 6, I think. 5 comma 6. Careful, that's y being 6. And then 4 comma 5. Is that right? Yeah. And then you could do the other ones too. What is that? 8 comma 5. No, that's not true. 8 comma 3. And then 7 comma 2. There. These are the points that you get automatically from doing the box method. And then you can contour around it, but you must curve through those 2 points. Contour. Same thing on this portion bottom here. Like that. Oh, so I cut off right there. I can't go over. There you go.
Okay.
You're done with the graph. Now let's do the detail. We got the VAHA, and we'll do domain and range right now. All right. Let's see. Based on the graph, again, okay, from left to right. Cover if you want. Okay, cover this portion, cover this up, and look from left to right, from negative infinity all the way to what is that? 6. So it's going to be negative. It's domain. Yeah, I'm sorry. We're not talking about increasing, decreasing here. Okay, but domain. All the x's. So all the x's is going to include negative infinity all the way to 6, not including 6 because of this asymptote right here. And then from 6, union, okay? I have to go over it on the other side of the page. 6 to positive infinity.
Okay.
That's for the domain. Parentheses. The range, look from the bottom up. So negative infinity all the way to 4.
Okay. So it's negative 54, and
then
the
union.
union between
And then 4 to infinity.
and infinity.
Yes, for range.
And then
okay, now increasing and decreasing. All right, then.
Whoa, and then this one has an increasing, but it
Yes.
doesn't have a decreasing.
No decreasing. Again, look at it. You can cover each side, and then go and then scan from left to right. Yeah. So it's basically going to be from negative infinity all the way to 6, right? Yeah, it was 6, not including. And then union, there should be union here, okay? And then from 6 to infinity for increasing. Decreasing, none.
Oh, wait.
Is that okay?
Yep.
Yeah, it looks like it's going up. Same thing with this. Oh, yeah, I can cover this part right here.
Is the increasing and or decreasing always the same as the domain?
Let me look at it. I never actually think about it because I look at the graph only. Can you imagine? I only look at the graph.
Because I don't know from the previous.
Yeah, it seems like you're right. So by the way, you're right. It's actually the same as the domain. However, is it increasing or decreasing? That depends on the graph. Yeah, is that okay? Yes, that's right. Okay, that looks good. And what else do we do? Okay, we didn't do the transformation of this one. The transformation it's easy. Let's talk about the transformation of this one quickly. You can say that the graph is shifted from the origin. Okay, from the origin. Now the order doesn't matter here how you word it, but you have to put all the elements in, right? So you're going to shift the graph from the parent function, like the origin, like the origin. You're gonna shift it to the right 1. So you say something like write 1. Oh, your teacher have some had some. Okay, we're gonna go by what your teacher write. So it's gonna be horizontal shift, H shift
Okay.
by 1. I'll go by your teacher by 1. Okay,
Okay.
and then vertical shift V I F T. Let me
By
see
5.
by 5. Okay,
And is that it?
let me double check.
Oh,
What did she do with this here? Vertical up to.
yeah, I think that's it.
Oh yeah, don't forget,
Right?
not just by 5. You want to say horizontal shift right 1. Sorry, right 1,
Oh,
and then
okay.
vertical shift up 5. Yeah, up 5. I'll try to mimic everything. Now, vertical stretch. Here's the thing: you don't write anything for that because it's the same as the parent function. It's 1. If it's a 1, you don't
Oh,
say anything. But if it's anything other than 1, like 3, then you say like what she did there. See, vertical stretch by 3. So this one,
so
let's do.
because for number 3,
Yeah,
it's a negative, would that be like not like the opposite of a
actually
stretch? I
no.
don't know what that's called, but
Actually, not quite. The negative, you have to describe
okay.
that separately. So let me show you right now. Let's do everything. I know we still have like the detailed x and y intercept.
Yeah, yeah.
Let's do the transformation since that's still in
Okay.
our minds right now. So we do a horizontal shift. Let's do that first. FT. Horizontal shift right by 6. Right 6. You don't need to. You don't need to write the word by the way. Right 6. Vertical shift up, up 4, up 4. Okay, now this part, let me do the negative first before I do the 2 because it makes more sense. You don't have to, by the way, you can do the order. You can do any order here. No kidding. Any order,
Hmm.
any order here, any order here, as long as you have all the
Okay.
elements. So let me, okay, oh, I can't, where, I cannot undo that. Okay, see.
I don't know.
Okay, there you go. All right. So, okay, next I will do the negative. So I'll even put a little label here, negative. The way you describe the negative is that you flip about,
Oh, is it
yeah,
a
it's
reflection?
reflection. Yes, okay. Let's
Oh,
use the what your teacher used.
I
Yeah,
don't know what she said, but
reflect, reflect, reflection or reflect.
would it be a anything special reflection or just
You
reflection?
reflect about the
Okay.
x-axis. You reflect about the x-axis. About or with respect to, depend how you. It's the same thing about the x-axis.
Okay.
Oh, continue. Okay,
I
x-axis.
get it. It's fine.
Or you may be able to say reflect. What do you call this right here?
That's
But yeah,
fine.
this technical, you can use x-axis, and then you're gonna say vertical stretch by 2
Why is it a stretch?
because of the 2. Yeah, because of this 2 right here. Just like how
When
she,
would it be
you see how she said right here, vertical stretch
yeah.
by 3. See that?
But
Because
when
of
would
that
it
3.
be what's it called? A compression.
When it's less than 1. Oh, good question. When it's less than 1, but you're not
What
going to
does
see
that
it.
even look
Yeah,
like?
yeah. If
Okay.
this were a 1/2, right, it will be basically the 2 will be in the denominator, be distributed in the denominator. If I'm making this up, if it were a one
Okay.
half on top, so yeah, you're not going to have to worry about compression for this particular type of graph. How about that? I'm talking about the 1/y graph. So yeah, so
Okay.
it's vertical stretch. If I can,
Okay.
if I can write it, because this thing is in the way. Vertical stretch, okay? Vertical stretch
Okay.
by 2. Vertical
Okay.
by 2. Factor of 2. Factor, you can use the word factor of 2. Okay, there you go. All right. Okay, I think we got everything except x
X
and y
and
intercept.
Y.
All right,
So
x and y intercept. Okay, let me squeeze it in somewhere. I'll squeeze it
um
in here. What is the original? Okay, I see. I got. Yeah, this particular format. Yes. the PDF format.
I mean, if you want, I have it all written down. If you want, you can erase some things.
Okay, good. Let me do that if I know how to erase it. Let me erase these here. But why can't it? Oh, there you go. All right, let's do x-intercept.
Yeah.
And y-intercept. And the eraser isn't big enough. What's wrong with this thing? I don't know how to, this app, I don't know how to actually,
I don't really. I never draw on it. I only use it to like write down what homework I need to do for the day.
right. Okay. Boy. All right. X-intercept. And it's laggy too. You noticed. Okay. X-intercept.
Oh, I thought that might just be my Wi-Fi.
Oh, no. So x-intercept, you let your y, substitute y equal to 0. So here we go. Negative. Oh, to make it easier, give the negative to the 2. Give up the negative to the 2. Yeah. Is that okay? If you didn't know that, you can do that. X minus 6. So it's a negative for the whole thing. Give the negative to the numerator. Negative to the whole fraction. Yeah. So give it to the negative. Give it to the 2. Okay. Subtract both sides by 4. Put a 1 underneath the negative 4. You okay? 0 minus 4, negative 4. And then cross multiplied. So if you cross multiplied, you would
So
distribute.
when cross multiplying, how do you know which goes on the left and right side?
Oh yeah, good question. You don't have to worry. You can put it wherever you want.
Oh, it doesn't matter?
Yeah, it doesn't
Okay.
matter. So I'll do 4 negative 4 times x minus 6 on the left side. Now I like the variable to be on the left side. That's why I do that.
Okay.
And then negative 1. I'm sorry, negative 2 times 1 is negative 2. I just write negative 2, and then distribute. So negative 4x plus 24 equals negative 2. Okay. Subtract both sides by 24. You're left with negative 26. And you 4x left here. Divide both sides by 4. It's not divisible by 4, but we can reduce it.
26 doesn't go into 4? Okay.
Yeah.
I didn't know that.
Wait, double check my math. Subtract both sides by 24. Yeah, it's negative
No,
26.
or 26, sorry.
Yes.
I
And
mixed
then,
words in my brain.
yes, we'll do a mixed number out of this, but it's nicer if you reduce it first. So half of it is 13, half of 4 is 2. So
Our teacher just likes us leaving it in improper fraction form.
sure, but the reason why you want to do a mixed number is so you want to make sure that your graph is right. Yeah? See that?
Oh,
Yeah, get it?
yeah.
Right? So you could go into, you're right, by the way. In algebra and calculus and pre-cal, they don't care for a mixed number at all. You're right. You're right about that. But I want to see in this one, what is that?
2 goes in
Uh,
13, 12, 6. Oh, 6 and
6
1/2.
times and 1/2, 6.5. So let's see. X 6.5. Yeah, you see it? It's 6 over right
Yep.
there. Yeah, it's at least I know our sketching there. That's all. So we got that one right. Pretty sure.
Okay.
Okay, y-intercept the same way. Do you have all this down? Let me go ahead and erase them. Or back. Oh, back is too slow. I have to erase it. Doing the undo is too slow. Let me erase it. Oh, let me erase all that too. I know.
Sorry, I didn't know the formatting was gonna be all weird. I would have tried
Yeah,
something else.
yeah. If you can make them like in JPEG image or something, it would have been much better for me to use. But I'll try to also figure out how I can convert the PDF. I'm sure there's a way to do it for sure. I just don't know how to do it for this quickly for the app. All right, so y-intercept. You substitute x with 0, so leave the y alone this time. So again, I will do negative 2 up on top there, being 0, x being 0 minus 6 plus 4. you'll be left with 1/3, positive 1/3 plus 4. So it's 4 and 1/3. You can leave it like that. Yeah, if you didn't know,
Oh,
it's the same thing.
4 1/3.
Yes, 4 and 1/3. This your teacher won't mind, okay, because it's quick.
Okay.
So it's 4 and 1/3, and it looks about right because it's above. You see right there, above 4. Yeah, you can see it right
Yeah.
there. Nice. That's it, I think. All right, let's move on. Tell me, how your other? What about your?
So, or you
Yeah.
go first. Sorry.
No, no. Your rational expression, multiplication, multiplying, adding, subtracting.
So, what I don't like, 9 is a good example, I think. So I already started doing it, but I got stuck because I got an x over 2, an x minus 5, x plus 5, x minus 2, and then x minus 2 is also on the bottom. And I didn't
Mhm.
know what I
Okay.
was supposed to do to
Okay.
get,
Okay. Got it. Don't forget, I think you have to write the restriction, right? Yes, you have
yeah,
to
I
write
did.
restriction.
I
So
didn't know how to do that at all either.
I recommend before you cancel anything out, you write the restriction after you factored right here. So I would
How do
I would note the
you...
restriction. The restriction would be x cannot be what will cause the denominator to be zero, all of it to be zero. Any part of the
Okay,
factor,
so it
so
can't be
-6,
6, -6,
2, and -3. It doesn't matter the
2.
order here. Oh, you got to do
And then
slash through. Okay, do the
what's
slash through.
removable and non-removable?
Okay, good. Your teacher even want that, right? Let me see
I've
the
never
instruction
heard of
carefully.
that.
Okay, got it. If you ever cross cancel the numerator over the denominator, it doesn't matter where it's located. It could be over here. You cancel that up here, out like that. That's removable.
Okay.
Yeah, so it's removable.
So, can I cancel out the x minus 2 and the
Yes,
x minus 2?
yes,
Oh, I can?
yes, you can. You have to for the final answer. But you have to note though. You have to note that removable. I don't know how you want to write it. Removable at 2. Opposite again. I know it's weird. You're gonna do the same thing like you were graphing. Removable. I don't spell that like that. At x equals 2. Opposite. Opposite this.
Okay.
Let me see. That's what your teacher want, right? Just label. Yeah, you have to
Yeah.
label removable. Okay, it's only A, no E.
So, so then what the final answer be?
The final answer. Let me see. Anything else? Yes. So your final answer should be removable, and not just at 2. It's also -6. You see it right here? Yeah. You
Oh,
cancel
because,
out the
yeah.
yeah. So you want to say x. Oh, I could just you can write
So if
two
you
x's.
cancel it out at all, then it becomes removable.
Exactly. If
Okay.
you yeah if you cancel if you don't cancel anything out, you don't write removable. But you still have to write the restriction. Is that okay?
Mm-hmm.
Yeah. Restriction can contain the removable points also. Is that okay? Yes.
Yep.
Right. So final answer should be x plus 5 and the 3. You don't have to distribute it in. Leave the 3 here.
Got it.
And then, yeah, you don't have to distribute. You could if you want. The denominator you should not distribute. The numerator you can. You'll know why when you
Oh, so do I not need a common denominator for this?
not for multiplying or dividing. Yeah. Yes.
Oh, that
Not
would
mo.
make things a lot easier.
Okay. Good. Good. I think that means we may have to review that, right? Whereas you're adding, subtracting over here, right? I think.
Adding, subtracting's on the last page that
Okay.
I sent you.
Okay. So is that okay so far? Let me double check your factoring. I think you got them right. I'm pretty sure. Yeah, you got them right. Yeah, yeah. Looks good. Good
So
job.
then for
The final answer.
number 4, it's at the very top. Can I cancel out the x minus? That's something I was unsure about the whole time. Like, can I
Yes.
cancel out the x minus 3?
Yes. You only
Okay.
do one pair though. You pick one. Pick the pair on the bottom.
And
Pick one.
then x minus 3 is removable.
Yes. Yeah.
Or
Don't forget.
3
Let's
is removable.
yes.
3
Do
is
the
removable.
yes. Three is removable, but you also still have to write the restriction. X not equals to.
Yeah.
Don't forget. Okay. 3, and then you label
3 and
removable
then
at 3.
minus 2.
Yeah. Yes.
And
That's
then
right.
isn't 2 minus 2 also? Or oh, it's just the
Yeah,
denominator.
it's just
Yeah.
the denominator. Removable, x equals 3. Opposite there, at x equals
Okay.
3. Is
And
that it?
then would
Yeah.
the final solution
It would be x
be
plus 2
x
over x
plus 2
minus
over
3.
x minus 3?
Yes.
Oh, okay, okay. So then I can, oh, that makes a lot more sense
Okay,
now that I
good.
can cancel everything out.
You can do this one too, but don't forget, before
Yeah.
I would normally do it before canceling. I would write the restriction, x not equals to 9 and not equals to negative 2, and then
And
removable.
then 2 is removable, 9 is non-removable. Okay. Yeah, that makes a lot
Yes,
more sense.
removable at x equals 2. Negative 2. Sorry.
Mm-hmm.
Negative 2. Okay, this one. Yes, cancel this out.
And then
Uh,
uh
the restriction x
it can't be 4.
can't be 4.
And then
Yes,
it's
and
removable.
removable
Okay, that makes sense.
x equals 4. Yes, you have to say equals. Okay, removable. It's equal. X equals
Okay.
4.
Can we do like 12? Or like 11? I don't know. Just something where I have to do something
Let me see.
else.
12. Oh, I want to. This is important. I'm glad you wait for me on this one. Factor everything first. Go for it. Let's do that right
Okay.
now. Now, keep the divide symbol for a bit.
Okay.
Let me see what we got here. 1 and 2. Oh, it's a minus plus. Okay, sorry. So it's a minus 2 plus 1. Doesn't matter which is first. Minus and minus. That looks right. Yes. Okay. And divide. 6 and
Oh, you got
uh,
2 and 3.
2 and 3. Yes, you're right. 2 and 3. No, 3 and 4, you mean. Right here. Minus 4 plus 3. And then 2x. 3. Maybe here. A plus and a minus 1 here. Let me double check. Yes, looks good. Okay, now right here, I have to say something. You might make a note for 12. You'll have to write the restriction this way, all the L shape backward. You have to do all of this
Okay.
here. The reason why is because you got the division one and then you got a flip flop, right? But when you flip flop,
Yeah.
this will be in the denominator. That's why you have to do the L shape backwards to include all the
So,
restrictions.
do you do that for only division?
Yes. If it's just multiplication, all you look at is the denominator for both expression, rational expression. Yeah, so make a note. L backwards when you do division for the restriction. So here we go. The restriction, here we go. All the restrictions will be positive 1/2, a 2. If it repeats, it's fine. Don't worry. You only have to write once. Negative 3 and 4. This is my negative 3 here, okay? And 4. There you go. All restriction. And then you could continue on from there. Before you do any remove, there's a removable here, but I would flip flop it first, the second
Okay.
expression, and
Like
I'll
the
let
keep change flip thingy?
yes, and I'll let you
Okay.
continue. Minus 2.
Yeah.
Here we go. We flip flop this here. X
So I don't
3.
know if it's in this study guide, but something that my teacher did a lot in like homework and just examples is like where they would multiply the bottom, like it would be like a singular fraction, and they would multiply the bottom by something that is like I don't know how to explain it. Like
Is it relating
uh
to common denominator?
go back to 9 really quick. So like uh imagine like I don't know, that 2 was a positive 3 or something. Then I would multiply the other side by x plus 6.
That's common denominator. Yes. So that,
I
yeah.
don't know what that's for, but I don't I remember doing
Okay.
that.
Let me find it. it has to do with common denominator. Now
Okay.
that 16
Sorry.
sounds like least. That's
Well,
yeah. It sounds like least common denominator. That what you're trying to describe there. Yeah. Well, let me. I can find it.
we
But
can
okay.
finish this one first, but like
Yes,
I
I
just
see it.
had to
No,
bring that
no,
up.
no worries. Okay, x equals 2 for removable anymore, and x equals 3 and negative 3. X equals 2 and x equals negative 3 because you can cancel one here. I'll double slash it like this, and then oh, there's more. Wow, I'll go this way, and also x equals 1/2 for removable. So there are like 3 removables here: negative 3, 1/2, and 2. I hope you can see that. And then whatever you have left, it just go ahead and I don't know how I even got that ruler there. Can you get rid of it? Oh, no. How to, how to get
How
rid
did
of
you
the ruler? Oh, no.
um
Oh, my gosh. Let's see. Somewhere here.
try the dots on the top maybe?
Oh, there you go.
Oh,
At least that
there.
helped. I don't know why. So this is what it's left. I think this is the final answer. Double check. Okay.
I'm just gonna guess myself.
Okay. So look at, yeah. Yeah, this is LCD going on right here for
So let's find the error.
24. Yeah. So, but I don't see the problem where you add and subtract anywhere.
It's on the last page,
Oh,
I
here.
think.
Okay.
That's
Right
like
here.
addition,
Sorry.
subtraction. That's the one done.
Okay. So let's do the one that I think is it's going to be what you need. Okay. Actually, I'll try to do a couple of common denominator right away. Do you want to? What do you want to do? Is that you factor the denominator right now? So let me go ahead and do this one. So you factor. It's going to be x plus 5, x minus 5,
Mm-hmm.
x plus 5. Okay. So could you tell me the LCD for this one? Do you remember how to do it? Okay. So
It's
let's
gonna be
review it.
x plus 5, right?
Actually, no, just the denominator, right? Common denominator,
Oh,
least common denominator. So let's review. There's 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 a fast way, which is the way that you should be doing, because the more complicated way is that you have to list them. You don't do that for x variable involved anyway. So let's see if you're going to be okay. So LCD, right? If you ever see the denominator being the same, you only need to write it once. So let's see, for example, the LCD, part of the LCD will be x plus 5. And then this one is different. So you're going to gather that as another factor. So this is your LCD. But I'm making this up. Hypothetically, let's say if this were to the second power, okay, you're going to gather
okay.
all the factors. I mean, this will be, but if you ever have one repeated like this here, you'll have to,
Okay.
you're going to extract the one that has the higher power, like right there. So here's the final answer for this problem that I modified. Let me go ahead and go back. So this is the original. Yeah, this is the original here. So this is going to be the LCD. And I hope you know how to continue from there. You have to multiply what's missing right here, and then continue. Distribute combine like terms in the numerator. But
Okay.
let me do the 17 quickly here, because you have I do have I have to continue with another student.
Okay.
But let me see. Factor 3x minus 2, 4x minus 3. Here we go. The LCD for this one. Double check my math here. Okay, LCD. Okay, now when you do the LCD, you look at the number part, the one that you factored out, and then you determine. Imagine, you know, 1/3. What's the common denominator between them? It's 12. You see that?
Mm-hmm.
Had this been a 6, I'm making this up, like a 6 here, then the LCD should be 6. Do you remember that? Like, because the smaller number can divide into it evenly. The LCD.
Yeah.
Recall? You want to recall? Let me. Oh, good. Let me undo
Sorry, I
it.
know you're running out of time.
Yes. So if this were 6 right here,
Mm-hmm.
it's like, hey, what is the least common denominator between 1/3 and 1/6? It got to be 6.
Three.
right?
Or
Yeah.
6.
Yeah, because you want to times it by 2 times it by 2. It's the least common denominator. It doesn't have to be, by the way. Yeah, if you don't get the number correct, as long as both 3 and 4 can divide into it, that means it could be 24. But when that happens, you no longer can be saying it as at least with the least common denominator. It's just a common denominator. But you can continue with it, but you have to reduce it later on. Imagine that, okay? It will be reducible. So keep that in mind. So right now, the LCD for the number part, it'll be between 3 and 4, it'll be 12. Just multiply them. If the bigger one cannot be divided by the smaller one, you multiply them. There you go. You can even write that down. 3 and 4. If the bigger number cannot be divided by the smaller one, go ahead and multiply them. That will be the number part for the LCD. Now, you're not done with the LCD for this here. You have the x minus 2 and x minus 3. They're completely different, right? That means you have to use both of them. So here it is, minus 2, x minus 3. There's your LCD, complete LCD. Had this been a 24 here, the whole thing will be considered as LCD. But we got the LCD. And then to continue from here, you have to make sure that this negative actually it's being distributed in. Okay, it's like a -1, but you don't want to do that just yet. But keep that in mind. You're going to distribute that. I would recommend you parenthesize that. But then you have to do the LCD first. The LCD, since the LCD is 12, this whole thing, this part is missing. It's not 12, so you have to times it by 3, and you also have to times it by x minus 2. So if you were to continue with this problem, this is the math that you should be doing. Times the top and the bottom by 3x minus 2. So how would you continue here? You have different ways to do it. You can give the 3. Oh my goodness. I would put the 3 right here and make it a -3. Is that okay?
Why is it
We're not done, by the way. We still have to do this
3x
side.
minus 2?
3x minus 2. Okay, because if you look at this fraction, right, you don't have it as the common denominator yet, the LCD. So you make it. You want to look at it? So this is the original. Well, the original denominator is here, but I need to make it look like the least common denominator. So you have to make it least common denominator. So I times it by 3, and I times it by what's missing, the x minus 2. Right here. You see that? You get that?
Yeah.
Let me do on this side. Maybe this will help. I didn't do this fraction yet. The denominator of this here is not the LCD. You gotta make it. So the LCD is 12, so I have to times this one by 4. Times this one by 4. But not just that, you have to times it by 4 times x minus 3, because that's what's missing. That means I have to times the numerator the same to this whole thing. So I recommend you parenthesize x minus 5. And this is long, by the way. You have to foil. I recommend you foil it first. Foil this, like separately. But keep this in mind. I recommend you put the 3 in front of the minus. So it become a -3. Try to imagine that, okay? So if I were to do this, it would look like this. Let me show you what it looked like. It would be a -3 times x minus 7, x minus 2. I would foil this and then distribute the -3. Imagine that, okay? I foil it and distribute -3. And then once you have everything foiled up, and this one too, foil, distribute the 4, then you'll combine the numerator, like terms, all of it together, with the common denominator being the same, like right here. Oh, do you want me to do this quickly?
No, I'm just confused with the left side really quick. Like about the factoring the things into it. Like I get the right
You,
side. I don't know why it's different for the left side, but it feels different.
the left side here?
Yeah.
Okay, so let me back here. Okay, if you notice, the original has 3x minus 2 coming from here. I factored it. If you look at this right here, it's not the same thing as this. So, okay, what's missing? Well, 3 is not 12. Therefore, I times it by 4 to make it 12. But but
Okay.
then but then this is the only thing that it has, the factor x minus 2. What's missing also is x minus 3. Therefore, it times by x minus 3 and 4 together.
Okay.
But whatever you do in the denominator, you do the numerator. Now, if you look at it carefully, okay, all this whole thing is the same thing as this whole thing. Same thing with that here too. See that? If you were to
Okay.
multiply it out, 12, x minus 3, x minus 2. The order doesn't matter there. Commutative property of multiplication.
Okay.
See that?
Yes, that makes sense.
But then do your very best to combine the numerators carefully. Again, like I said, I recommend you give up the 3, put it in the front of the negative. And then, watch, let me do this. Let me rewrite it. Put that 3, this 3 right here, put it in right here. And like you reorganize it to make it clean for you to work on it. And then you foil it. Then you foil the x minus 3, x minus 2, I'm sorry, x minus 7. Yeah, x minus 7 times x minus 2. Foil that. Foil it, you get a trinomial, and then distribute the negative 3 into it. And then,
Okay, that makes sense. Yeah, yeah, yeah. I get
and then
that.
wait for this one, the same, and then combine like terms. Then you're good to go.
Okay.
And then you should
Okay.
be done right there. Now,
Okay.
you may, after you combine everything, you may want to attempt to factor it one last time. But from what I can tell, it's likely not going to be anything that can cancel out with the denominator. Yeah. So I do have another student, by the way. He
Yeah,
might be
I
in your
know
class.
another story.
Wait, no, I'm sorry. I was going to say in your class, not after here. I wanted to explain. I recognize these problems in his work. That's why I'm telling you that
Oh, really?
this is likely that you after you combine the numerator, it would not be, you could factor the numerator, but you cannot, from what I remember working with him, you can factor, some can be factored, some cannot be. The one that you can factor cannot be canceled out with the denominator. Therefore, after you do everything in the numerator and you have to denominate, you're done. Is that all right? Is that
Oh,
okay? Combine so
okay.
that you'll be done. So yeah, I want to point that out. There's somebody in your class, possibly, I don't know, but it doesn't look exactly the same. But the actual topic, the actual type of problems, they're the same.
He
You might
might have
have
a
the
different
B.
teacher.
Yeah, you're right. Yeah. So yeah, that's it. Okay. Hey, what do you think? Do you think you're gonna be okay? Now,
I think, yeah.
for the equation problem, okay, you have to find the LCD. Let me do this quickly. Okay, let me see. 4 and minus 3. Yes. Okay, check it out. Okay.
Oh, this is what I was kind of talking about too.
Yes. Okay. 1 second. Let me.
If you need to go, it's fine. I think I get those ones now. After you explain like 17, I think that makes sense.
Okay. Yes. Okay. Now the LCD. Let me look at this carefully. If you look at the LCD for
Mm-hmm.
this equation, you want to establish it. So let me go ahead and write it up here. Okay. LCD for this equation will be x minus 4, x minus 3, and that's it. How do I know? Because these fraction denominator of the fraction, each has this portion. I mean, the factors. It's in the factor of the LCD of this one. How about that?
Okay.
You see that? That means the LCD
Yeah.
of the whole equation is this here. And then what do you do
Okay.
from here? I don't know which method have your teacher taught you, but normally when you're here, when doing all of this together, you will likely have to do it this way. Let me show it to you. You're going to multiply the numerator, the left side and the right side by the LCD. It will look like this. You're going to
That's
times,
what she does. Yeah.
okay, good. So you're going to times this 5 by this and the 2 by this. But let me see what it looks like. So, and this 5 by the same LCD. Okay,
Okay.
when you do this, what will happen is this. This will cancel out with this cancel with this, and this will cancel with that. So what you have left will look like this. Ignore all this here. What you have left is going to be 5 only in the for the left side. 5.
Okay.
Okay, let me continue. 5 and plus 2 parentheses x minus 4. Yeah, you do the whole thing to get rid of the denominators of the equation, the whole denominator on both sides of the equation. So this is what you're supposed to have on the left side. And the right side, you will have this 5x minus 3. And then you continue. You can solve this one.
Okay. That makes
But
sense.
then,
Yeah.
but then you still have, after you can do it now or after you finish. You still have to state the restriction. You're going to go on. I would recommend you do it before you finish the equation. I recommend you do it like after you factor this right here. So restriction, here we go. X not equals 2, 4, 3. The opposite. Is that okay? Yeah, write it somewhere in the problem. Kind of bubble it even.
So the reason it's no solution is because the answer was 4, and then the restriction it can't be 4.
Wait, you already got the solution to number 20?
It's just one of the example teacher ones.
Oh, let me see why. Yeah, okay, there it is. It looks the same as mine here. Oh, I
But
didn't
so
see the
I
bottom.
thought that was kind of weird because
Okay. Yes. Okay. If you answer, okay, check this out. It's not common, but but it's going to be on the test, at least one. So let's pretend this is the one. So it looks like it's 4, right? Is that what the answer is?
yeah,
Is that
that's a 4.
okay? So if the answer happens to be the restriction, get it? That's why you list the restriction first. If it happens to be one of the restriction, there's no solution. You say no solution immediately.